This is a system of linear equations in which we want to solve it using the addition method. When you use the addition method, the concept is to get the coefficient in front of the same variable in each equation to be the same thing. So for instance, if you have a 2x here, you'd want a negative 2x here. So you want the same value but opposite signs. In this case, the easiest term to get in front of each variable would be the y's. If we were to multiply this y by a negative 7, then that would give us a positive 7y here and a negative 7y here. So another case that we could use is the x's though. It's perfectly okay to use either situation. We could also get the opposite number in front of each x, and in order to do that, we would need to get a 6 in front of each one, because the least common multiple between 2 and 3 is 6. It's just like finding an LCD. So we would have to multiply the first equation by a negative 3 and the second equation by a positive 2 to get just the same value in front of each x with opposite signs. In this case though, we will work with the y's as it is easier. So we're going to multiply each number in the top equation by a negative 7. We're doing that because it's going to give us the exact same equation. As long as we multiply it to every term, the problem will not be changed. And at the same time, this negative 7 times this negative y will give us positive 7y, which will be the opposite sign of this negative 7y, which is exactly what we need. So we'll multiply this negative 7 to each term. That gives us negative 14x plus 7y equals negative 35. And from here we just copy the second equation down just as it was. And now the addition method says we can add these two equations together. So we're going to combine like terms. We have negative 14x plus 3x gives us negative 11x. Positive 7y minus 7y is going to cancel out. So we'll get that this is equal to negative 35 plus 2 is negative 33. And to get x alone, we'll divide each side by negative 11, which gives us x equals positive 3. Okay, so from here, we now go back to either one of our original equations, and we plug this 3 in to solve for the y value that we don't know. And in this scenario, it will more than likely be easier to solve the first equation as there's less information in front of the y. We only have a negative y instead of a negative 7y like we did in the second. So we'll take the first equation, 2x minus y equals 5, and we'll plug that 3 in for the x to get 2 times 3 minus y equals 5, which gives us 6 minus y equals 5. Subtracting 6 from each side to get the y alone gives us negative y equals negative 1. And finally, dividing each side by negative 1 gives us y equals positive 1. So our solution in this case is the point of intersection of these two equations, which is the point x comma y, which means we get the point 3 comma 1.